22152 ZE1 Series. Instruction Manual. CC link function. Read and follow these instructions and all safety blocks carefully. Have only trained and qualified persons install, operate, or service this unit. Give this manual to the operator. For help, call your distributor. Be sure to read instruction manuals before use. Thank you for selecting Den Arc Welding Robot All Mega Series. All Mega Series are the robots with high performance and various functions developed by making full use of the latest technology. Since the knowledge of welding peculiar to a welding machine maker is applied to both hardware and software, we are sure that each user can be fully satisfied in order to use the superior performance and the abundant functions safely and fully. Be sure to read the following instruction manuals including this manual and other attached documents, and understand the knowledge of the machines, safety information, and notes thoroughly. Instruction manuals related to the manipulator/per hour series and the Robot Control Unit FD11 are as follows. Standard manuals. Instruction manual type instruction. Manual no. Main contents. Quick start 1L21700 a point on safety, transportation and installation, turning the power on/off and manual operation, etc. Setup. 1L21700B. Safety precautions. Installing and connecting method. Starting up. Periodical inspection. Solution at the time of failure. Controller maintenance 1L21700K specifications of controller, explanation of each parts, and maintenance, parts list, etc. Manipulator NB4/NB4L/NV6/NV20/NH51L11130 a specifications or maintenance of manipulator, parts, list, etc. Basic operations. 1L21700C. Explanation of manual operation, teaching, automatic operation, file utilities, backing up data, basic operations of arc/spot welding application, etc. External input/output 1L21700H interfacing method with external control device, list of I/O signals and start/halt the automatic operation, etc. Software PLC 1L21700J create program, input/output relay lists, list of command words, etc. Control and maintenance function 1L21700L edit logging, user check, troubleshooting, etc. Application manuals. Instruction manual type instruction. Manual no. Main contents. Application manual arc welding 1L21700F basic settings. Functions for arc welding, teaching, technique, etc. Application manual spot welding 1L21700E basic settings. Functions for arc welding, teaching, technique, etc. Instruction manuals are available other than the above for each optional function that you have purchased. Notes 1. Specifications and information contained in these manuals are subject to change at any time without notice. 2. The screen display of a teach pendant shown in the manual are described as examples, which may be different from the actual ones. 3. Although we cautiously compiled this standard specifications to eliminate as much error as possible, we do not take any responsibility for damages resulting from neither direct nor indirect errors. 4. The manual is a part of robot products. When transferring or selling off a robot, be sure to append the manual. 5. No part of this manual may be reproduced without permission. 6. Prohibited altering or remodeling. Do not alter or remodel our products. You may get injured or have your equipment damaged because of fire, failure or malfunction caused by altering or remodeling the product. The warranty does not cover any altered or remodeled products. -1 notice. Notes on safety. Before installation, operation. Be sure to read Chapter 1 Points on Safety in Setup Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. Furthermore, before maintenance, inspection, and troubleshooting, be sure to read Controller Maintenance Manual and Manipulator Manual and other attached documents thoroughly and acquire all the knowledge of machines, safety information, and precautions. If operating machines in a wrong way, the accident resulting in various ranks of injury or death, or damage may occur. In order to call attention to wrong handling, the following 4 ranks of safety notes: danger, warning, caution, and important are provided. Danger. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury and where the degree of the urgency imminence of the warning given for the danger to occur is at the high end of the scale including high-level danger, -2 warning. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of death or serious injury, caution. Cases where a mistake made in handling is likely to cause the user to be exposed to the danger of minor injuries or of property damage only. The following symbol is also used for particularly important checkpoints. Important. This is a particularly important checkpoint. Note that even the matters which are described as caution can result in serious accident depending on the conditions. Be sure to keep the safety notes since they describe very important matters. The meanings of serious injury, minor injury, and damage described above are as follows. Serious injury, injury which has the after effect by loss of eyesight, and injury, the burn high/low, temperature, and electric shock, fracture, poisoning, etc., and that which requires hospitalization and long-term treatment as an outpatient. Minor injury, injury which does not require either hospitalization or long-term treatment as an outpatient. A burn high temperature, low temperature, and an electric shock. Damage, direct and indirect damage in connection with damage of property and equipment. Table of contents. Table of contents. Chapter 1 Outline. 1.1 What is CC-Link? 1-to-1. 1.2 CC-Link functions of this controller. 1-to-2 1.2.1 Construction of I/O signals. 1-to-2 1.2.2 Performance table. 1-to-3 1.2.3 Installing location. 1-to-4 1.2.4 Hardware. 1-to-5 1.2.5 Cable connections. 1-to-6. Chapter 2 Needed parts. 2.1 Needed parts. 2-to-1. Chapter 3 Signal allocation. 3.1 The field bus input/output signals. 3-to-1 3.1.1 When the software PLC is enabled. 3-to-1 3.1.2 When the software PLC is disabled. 3-to-1 3.1.3 Input/output allocation across channels. 3-to-2 3.2 CC-Link signal allocation. 3-to-3 3.2.1 When used as a slave. 3-to-3 3.2.2 When used as the master. 3-to-4. Chapter 4 Operation. 4.1 Setting procedure. 4-to-1. 4.2 CC-Link settings. 4-to-2 4.2.1 Field bus settings. 4-to-2 4.2.2 CC-Link master settings. 4-to-3 4.2.3 CC-Link slave settings. 4-to-5 4.2.4 Operation check. 4-to-6. Chapter 5 Error detection. 5.1 Error detection on CC-Link board. 5-to-1. 5.2 Error detection on this controller. 5-to-2. 5.3 Detail setting of field bus error. 5-to-3. 1 Table of contents. 2. Note 1.1 What is CC-Link? Chapter 1 Outline. 1.1 What is CC-Link? CC-Link Control and Communication Link refers to a field network system that can achieve controlling and processing information data simultaneously and rapidly, in order to meet the various needs of the users of FA system, by enabling network connections for limit switches, photo sensors, operation boards, robots and other industrial devices, and by enabling logical access to the inputs and output network I/O provided by each of these devices. CC-Link improves communication between devices, which is difficult to achieve through hardware connections, and it enables diagnoses for each individual device. The maximum number of nodes in the network is 64, and the baud rate can be set from 156 kilobit per second to 10 megabit per second in accordance with the size of the network. Following figure is an example where this controller is connected to CC-Link as a slave. Terminating resistor, sequencers, sensors, I/O devices, robot, control unit, PC master, robot body, Fig. 1.1.1 CC-Link connections diagram. The CC-Link function enables to be connected to CC-Link as shown above. These functions make it possible for this controller to function as the master or as a slave or both in CC-Link, and for the I signals and other general purpose input/output signals to be operated across the network. CC-Link is a registered trademark of CC-Link Partner Association. 1-to-1 1.2 CC-Link functions of this controller. 1.2 CC-Link functions of this controller. 1.2.1 Construction of I/O signals. Up to 4 independent networks channels are supported by the CC-Link functions of this controller. In each of these channels, this controller functions independently either as the master or as a slave. An operation block diagram of the CC-Link functions is presented below. I/O that can be operated by this controller. Inputs I0001 I2048, outputs O00010 2048. Inputs I1 I2048, outputs O10 2048. PLC. Inputs I0001 I0032, outputs O00010 0032. Inputs X0000 X0031, outputs Y0000 Y0031. I/O board standard. Inputs X1000 X3047, outputs Y1000 Y3047. Field bus. I/O board standard. Inputs I0161 I2048, outputs O01610 2048. Field bus. Software PLC not in use. Software PLC in use. Supplement I/O board and field bus function are both optional when purchasing. Either one need to be selected. Fig. 1.2.1 CC-Link function operation block diagram. There are 2 ways of accessing the network I/O from this controller when the software PLC is used. Access is performed through the field bus I/O with 2048 input contacts X1000, X3047, and 2048 output contacts Y1000, Y3047. When the software PLC is not used, it is performed through the logical I/O with 1888 input contacts I161, I2048, and 1888 output contacts O161, O2048. See Note 1. Note 1. If all logic port numbers are allocated to fieldbus I/O through the hardware settings, the I/O will be 2048 contacts. 1 to 2 1.2.2 Performance Table 1.2.2 Performance Table Table 1.2.1 Performance Table Item Specification Number of channels Maximum number of channels installed 3 Master/slave can function as master or slave. Master or slave can be set independently for each channel. When using it as a slave, set it as an intelligent device station on the master side. Number of inputs/outputs when used as a master. A maximum of 2048 inputs 256 bytes and 2048 outputs 256 bytes can be used for all the channels, and these numbers cover all the general purpose signals of this controller. When the software PLC is used, number of inputs/outputs when used as a slave. When remote registers are not used, up to 112 inputs and 112 outputs can be used. When remote registers are used, a maximum of 368 inputs and 368 outputs can be used. Number of slaves connected. Up to 64 slave stations can be connected to one master station. Note that the following conditions must be satisfied. 1 asterisk A plus 2 asterisk plus 3 asterisk C plus 4 asterisk 64. A. Number of stations occupying 1 station. Number of stations occupying 2 stations. C. Number of stations occupying 3 stations. Number of stations occupying 4 stations. 216 asterisk A plus 54 asterisk plus 88 asterisk C 2304. A. Number of remote I/O stations 64 or less. Number of remote device stations 42 or less. C. Number of local stations, waiting master stations, and intelligent device stations 26 or less. 332 multiplied by alpha plus 32 plus 64 multiplied by beta. 2048 PLC is used. 1888 PLC is not in use. Alpha, number of stations using no remote registers. Beta, number of stations using remote registers. Node address by means of key input from the teach pendant. The node addresses at this controller side can be selected from 1 to 64 and set for each channel. Baud rate 5 steps. From 156 kilobit per second to 10 megabit per second, can be set enabling the optical rate for the scale of the network to be selected. Input data processing when communication trouble has occurred. It is possible to select whether the input signal statuses are to be held or cleared when communication trouble has occurred. Connection precautions. If this controller is the last device connected to the network, a terminator, terminating resistance, should be connected. Listed below are the possible causes of trouble. Broken or disconnected cable. Mismatched baud rate. Erroneous node address. Setting. Trouble in CC-Link board hardware. Caution. If an error has occurred or a LED indicating trouble lights up, the I/O statuses may not be correct. Care should be taken since this may cause the robot, jigs and other interlocks to fail to operate correctly, possibly resulting in a sudden or unanticipated operation. Important. There is a case that intelligent device station cannot been selected according to the device type. Before use, please confirm that intelligent device station can been selected. 1 to 3 1.2 CC-Link functions of this controller. 1.2.3 Installing location. CC-Link board is in use by installing to one of PCI slot. Please remember its location slot ID number 1 to number 3, because this number needs to be set later. Number 1, number 2, number 3, ID. Setting screen of PCI slot ID, Fig. 1.2.2 PCI slot. 1 to 4 1.2.2 Performance Table. 1.2.4 Hardware CC-Link board, Q80BDH61BT11. Although CC-Link board, Q80BDH61BT11, itself can support CC-Link v2. This controller can support only CC-Link v1.0. The connectors are as shown below. Q80BDH61BT11N. Cable connectors. LED SDRD. Run air. 153mm. 121mm. 141mm. 158mm. 90mm. 99mm. 19mm. Fig. 1.2.3 CC-Link board. Q80BDH61BT11N. SLD. DB. DG. Fig. 1.2.4 Detailed diagram of cable connectors. If the channel is located at the end of the network, terminating resistances must be connected. 1 to 5 1.2 CC-Link functions of this controller. 1.2.5 Cable connections. Connect the CC-Link connector bracket AX10 98 to the CC-Link board, and then mount this assembly to the CPU rack of this controller. CC-Link board connector connection bracket, cable provided, Fig. 1.2.5 connection between CC-Link board and CC-Link bracket. After the completion of mounting the printed circuit board, connect the cable directly to the connector provided on the connector connection bracket, CPU rack, CC-Link connector connection bracket, CC-Link cable, Fig. 1.2.6 connection of CC-Link cable, pin number 1, 2, 3, 4, 5, 6. Pin number signal name, function 1 terminal block, mounting hole 2 DA signal line, a 3 dB signal line, B4DG digital GND5 SLD shield, 6 terminal block mounting hole, Fig. 1.2.7 enlarged view of terminal block, 1 to 6 2.1 needed parts, 2 to 1, chapter 2 needed parts, 2.1 needed parts. Following optional are needed to implement CC-Link function. Table 2.1.1 optional parts for CC-Link function. Parts name type, CC-Link board, master, or slave. L22354C2 to 2. Note 3.1 the field bus input/output signals, 3 to 1. Chapter 3 signal allocation, 3.1 the field bus input/output signals. The field bus input/output signal attributes differ depending on whether the software PLC is enabled or disabled. The signal allocation positions are also determined by the numbers of the field bus channels used. 3.1.1 when the software PLC is enabled. If the software PLC is enabled, the signals are allocated to the field bus relay inputs X1000 X3047 and outputs Y1000 Y3047. Table 3.1.1 input/output allocation when software PLC is enabled. Channel number input-output number of signals. Channel 1 X1000 X1511 Y1000 Y1511 512 64 bytes. Channel 2 X1512 X2023 Y1512 Y2023 512 64 bytes. Channel 3 X2024 X2535 Y2024 Y2535 512 64 bytes. Channel 4 X2536 X3047 Y2536 Y3047 512 64 bytes. Total 2048. 3.1.2 when the software PLC is disabled. If the software PLC is disabled, the signals are allocated to the inputs I161 I2048 and outputs O161 O2048 of the general purpose input/output signals. Table 3.1.2 input/output allocation when software PLC is disabled. Channel number input-output number of signals. Channel 1 I161 I672 O161 O672 512 64 bytes. Channel 2 I673 I1184 O673 O1184 512 64 bytes. Channel 3 I1185 I1696 O1185 O1696 512 64 bytes. Channel 4 I1697 I2048 O1697 O2048 352 44 bytes. Total 1888. 3.1 the field bus input/output signals, 3 to 2. 3.1.3 input/output allocation across channels. The field bus can use up to 4 channels. However, if not all 4 channels are going to be used, the signal allocation area of the disabled channels can be used. The description below uses a case where the software PLC is enabled as an example. Even when the software PLC is disabled, the allocation can be used under the same approach. If only one channel is going to be used, all 2048 inputs and outputs can be used by channel 1 alone if channel 1 is used. Table 3.1.3 input/output allocation when only one channel is used. Channel number input-output number of signals. Channel 1, Channel 2, Channel 3, Channel 4. X1000 X3047 Y1000 Y3047 to 2048 256 bytes. If 2 channels are going to be used, 1024 inputs and outputs can be used by each channel if channels 1 and 3 are used. Table 3.1.4 input/output allocation when 2 channels are used. Channel number input-output number of signals. Channel 1, Channel 2. X1000 X2023 Y1000 Y2023 to 1024 128 bytes. Channel 3, Channel 4. X2024 X3047 Y2024 Y3047 to 1024 128 bytes. 3.2 CC-Link signal allocation. 3 to 3. 3.2 CC-Link signal allocation. The head signal position is determined depending on which field bus channel the signals have been set in. In the case of CC-Link, the signal positions are also determined by the number of the occupied stations, which has been set for the slave. 3.2.1 When used as a slave. If this controller is going to be used as a slave, the signals are simply allocated from the signal positions determined by the channels. The number of the occupied stations is fixed at 4. Therefore, 112 inputs/outputs are available. *1. If no remote registers are used, a local station will be able to use 128 I/O at maximum, since 16 of them are occupied as the system I/O. However, the station will be able to freely use 112 I/O at maximum. *2. If remote registers are used, a local station will be able to use 384 I/O at maximum, since 16 of them are occupied as the system I/O. However, the station will be able to freely use 368 I/O at maximum. The following section shows the signal allocation when this controller is used as the slave. Table 3.2.1 Signal allocation when no remote registers are used. Channel 1, Channel 2, Channel 3, Channel 4 PLC enabled, PLC disabled, PLC enabled, PLC disabled, PLC enabled, PLC disabled, PLC enabled, PLC disabled. Number of I/O, X1000, to X1111, I161, to I272, X1512, to X1623, I673, to I784, X2024, to X2135, I1185, to I1296, X2536, to X2647, I1697, to I1808, remote I/O, Y1000, to Y1111, O161, to O272, Y1512, to Y1623, O673, to O784, Y2024, to Y2135, O1185, to O1296, Y2536, to Y2647, O1697, to O1808, 112, X1112, to X1127, I273, to I288, X1624, to X1639, I785, to I800, X2136, to X2151, I1297, to I1312, X2648, to X2663, I1809, to I1824, system region unusable, Y1112, to Y1127, O273, to O288, Y1624, to Y1639, O785, to O800, Y2136, to Y2151, O1297, to O1312, Y2648, to Y2663, O1809, to O1824, 16, X1128, to X1511, I289, to I672, X1640, to X2023, I801, to I1184, X2152, to X2535, I1313, to I1696, X2664, to X3047, I1825, to I2048, unallocated region, Y1128, to Y1511, O289, to O672, Y1640, to Y2023, O801, to O1184, Y2152, to Y2535, O1313, to O1696, X2664, to X3047, O1825, to O2048, 384 asterisk with PLC disabled. The number of I/O for the unallocated region of channel 4 will be 224. Table 3.2.2 Signal allocation when remote registers are used. Channel 1, Channel 2, Channel 3, Channel 4 PLC enabled, PLC disabled, PLC enabled, PLC disabled, PLC enabled, PLC disabled, PLC enabled, PLC disabled. Number of I/O, X1000, to X1111, I161, to I272, X1512, to X1623, I673, to I784, X2024, to X2135, I1185, to I1296, X2536, to X2647, I1697, to I1808, remote I/O, Y1000, to Y1111, O161, to O272, Y1512, to Y1623, O673, to O784, Y2024, to Y2135, O1185, to O1296, Y2536, to Y2647, O1697, to O1808, 112, X1112, to X1127, I273, to I288, X1624, to X1639, I785, to I800, X2136, to X2151, I1297, to I1312, X2648, to X2663, I1809, to I1824, system region unusable, Y1112, to Y1127, O273, to O288, Y1624, to Y1639, O785, to O800, Y2136, to Y2151, O1297, to O1312, Y2648, to Y2663, O1809, to O1824, 16, X1128, to X1383, I289, to I544, X1640, to X1895, I801, to I1056, X2152, to X2407, I1313, to I1568, X2664, to X2919, I1825, to I2048, remote register, Y1128, to Y1383, O289, to O544, Y1640, to Y1895, O801, to O1056, Y2152, to Y2407, O1313, to O1568, Y2664, to Y2919, O1825, to O2048, 256 *1, X1384, to X1511, I545, to I672, X1896, to X2023, I1057, to I1184, X2408, to X2535, I1569, to I1696, X2920, to X3047, unallocated region minus, Y1384, to Y1511, O545, to O672, Y1896, to Y2023, O1057, to O1184, Y2408, to Y2535, O1569, to O1696, X2920, to X3047, minus 128 *2, *1 with PLC disabled. The number of I/O for remote registers of channel 4 will be 224, *2 with PLC disabled. Channel 4 has no unallocated region. 3.2 CC link signal allocation. 3.2.2 when used as the master. If this controller is going to be used as the master, The signal positions are determined by the sequence in which the slaves are displayed on the slave list screen. The slave list is set on the screen below. For the operating procedure, refer to Chapter 4. The signal allocation is determined by the number of occupancy stations by each slave. Given below is an example of signal allocation when channel 1 is made to serve as the master. Table 3.2.2 Example of master signal allocation. Number of station, type of station, signal name, signal allocation with PLC enabled, signal allocation with PLC disabled. Number of signals. Remote I/OX1000 to X1111, Y1000 to Y1111, I161 to I272, O161 to O272. 1 remote I/O station 112. System region unusable. X1112 to X1127. Y1112 to Y1127. I273 to I288. O273 to O288. 16. Remote I/OX1128 to X1175. Y1128 to Y1175. I289 to I336. O289 to O336. 5 remote device 48. Station. System region unusable. X1176 to X1191. Y1176 to Y1191. I337 to I352. O337 to O352. 16. Remote I/OX1192 to X1207. Y1192 to Y1207. I353 to I368. O353 to O368. 16. System region unusable. X1208 to X1223. Y1208 to Y1223. I369 to I384. O369 to O384. 16. 7 Intelligent station. Remote register X1224 to X1287. Y1224 to Y1287. I385 to I448. O385 to O448. 64. Remote I/OX1288 to X1303. Y1288 to Y1303. I449 to I464. O449 to O464. 8 Remote I/O station 16. System region unusable. X1304 to X1319. Y1304 to Y1319. I465 to I480. O465 to O480. 16. Remote I/OX1320 to X1335. Y1320 to Y1335. I481 to I496. O481 to O496. 9 Remote I/O station 16. System region unusable. X1336 to X1351. Y1336 to Y1351. I497 to I512. O497 to O512. 16. Caution. Depending on the station type, slave/master, manufacturer, etc., of the device, there are some cases where the device does not have a system region. For the details of the system region, please refer to the instruction manual of those devices. 3 to 4 4.1 Setting Procedure. Chapter 4 Operation. 4.1 Setting Procedure. Shown below is the general sequence of the steps for performing the setting. Master. Hardware connections. Start. Field bus settings. Set the number of the field bus channel to be used, the master and the slaves, and the slot ID where the CC-Link board has been installed. CC-Link master settings. Set the baud rate, master node number and the action to take when transmission errors occur. Slave list settings. Set the type of the local stations, the number of stations occupied, and select whether to reserve or disable the stations. CC-Link slave settings. Set the baud rate, slave node numbers, number of input/output bytes, and the action to take when transmission errors occur, and yes, no, Fig. 4.1.1 Setting Procedure Flowchart. When the software PLC is used for field bus input/output signals, the software PLC settings must be performed as well. For further details, refer to Software PLC Manual. 4 to 1 4.2 CC-Link Settings. 4.2 CC-Link Settings. 4.2.1 Field Bus Settings Protocol Settings. 1 Select Constant Setting -8 Communication 3 Field Bus. A setting screen for each channels, such as the one shown below, appears. 2. Align cursor with channel combo box, and select CC link. +3. Select master or slave with enable and left or right cursor keys. 4. Align cursor with slot ID combo box, and select slot ID number where CC link board is inserted, number 1 to number 3. Now proceed to set the CC link master or CC link slave. 4.2 CC link settings. 4.2.2 CC link master settings. Channel settings. 1 on the Fieldbus screen. Align cursor with the channel where CC link master has been selected, and press refer F key in the figure below. Channel 1 is selected. Following screen now appears. Align cursor and set needed parameters. Baud rate. A baud rate from 156 kilobit per second to 10 megabit per second can be selected. The same baud rate must be set for all the devices in one network. Connect no. Input the number of slaves to be connected to the master. Auto clear inputs. It is possible to select whether the input signals from the CC link are to be held or cleared when communication trouble has occurred. 2. 3. This now completes the settings of the master. However, for use as the master, the slave devices connected to the master must also be set. Proceed with the slave list settings starting with the next item. 4. Upon completion of the settings, press the F12 OK key. Now continue to the setting of slave list. 4.2 CC link settings. Slave list settings. 1. Press slave list F key on the CC link master detailed settings screen. Following screen now appears. Align cursor and set needed parameters. Stop. Type select one of remote I/O, remote device, or intelligent, and press enter key. When this controller is to be connected as a slave, select intelligent device station. Occupancy stop. Select one of 1, 2, 3, or 4 stations, and press enter key. When this controller is to be connected as a slave, select 4 stations. As soon as the number of the occupancy stations is set, the station number is updated automatically. Reserve stop. Select one of no setup, reserve, disable, and press enter key. Normally select no setting. If reserved is selected, no error is detected, even though it is not connected to the network. If disabled is selected, this station is considered not to exist. Register. Select one of disabled or enabled, and press enter key. If enabled is selected, in addition to normal I/O, remote registers with 64 I/O per station can be used. If the type of station is set to remote I/O station, this item cannot be set to enabled. Furthermore, if the type of station is switched to remote I/O station, the set value of this item will be automatically switched to disabled. 2. 3. Upon completion of the settings, press the F12 OK key. The display now returns to the CC link master settings screen. Important. In order to use remote registers, the remote registers should be set to enabled on both the slave and the master. If the setting of remote register enabled/disabled on the master disagrees with that on the slave, any error or else is not detected, but the remote registers cannot be used. For the method of enabling the remote registers of devices to be connected to this controller, refer to information in the operating manual of each device. 4.2 CC link settings. 4.2.3 CC link slave settings. Channel settings. 1 on the Fieldbus screen. Align cursor with the channel where CC link slave has been selected, and press refer F key in the figure below. Channel 2 is selected. Following screen now appears. Align cursor and set needed parameters. Baud rate. A baud rate from 156 kilobit per second to 10 megabit per second can be selected. The same baud rate must be set for all the devices in one network. Slave MAC ID. The node numbers 1 to 64 denote the station numbers of the CC link. Remote register if enabled is selected. In addition to normal I/O, remote registers with 64 I/O per station can be used. Auto clear inputs. It is possible to select whether the input signals from the CC link are to be held or cleared when communication trouble has occurred. 2. 6. Upon completion of the settings, press the F12 OK key. The display now returns to the Fieldbus screen. Settings for the master. When this controller is used as a slave, perform the following settings for the master. Stop. Type intelligent device. Occupancy stop. 4 stations. It is not necessary to set buffer specification for intelligent devices. Important. In order to use remote registers, the remote registers should be set to enabled on both the slave and the master. If the setting of remote register enabled/disabled on the master disagrees with that on the slave, any error or else is not detected, but the remote registers cannot be used. For the method of enabling the remote registers, refer to information in the operating manual of each device. 4.2 CC link settings. 4.2.4 Operation check. The Fieldbus monitor is used for confirming that CC link channels that have been set are working correctly. Note that the Fieldbus monitor can be operated only by an operator with qualifications class of expert or higher. Fieldbus monitor. Select service utilities. 3 monitor 1, 4 monitor 2, 5 monitor 3, 6 monitor 4. Fieldbus monitor Following monitor screen now appears. ***, this is the channel number. CC, this denotes the network type. CC is displayed for the CC link. MSDARC/SLV. This indicates whether this channel is set as the master/slave of Q80BDH61BT11N. Node ********. This indicates a node slaves connected to the network. When the channel concerned is used as the master, the node number is displayed. Device begin scan. The device is working correctly. 1. Device idle. The device is not working. If the device is not working correctly, the status is displayed in a red frame. 2. Scroll the monitor. 4 to 6. 5.1 Error detection on CC link board. Chapter 5 Error detection. 5.1 Error detection on CC link board. The CC link board uses the 4 LEDs shown in the figure below to indicate the current status. LED Q80BDH61BT11N SDRD Run Air SDRD Run Air Fig 5.1.14 LEDs. Table 5.1.1 Status of LED and the CC link board. Name of LED on off. Details run CC link board in the normal status. WDT error power off. Lights when the CC link board is in the normal status, and goes off when a WDT error occurs. Air. Data link communication error. Data link communication error. Lights when a network communication error occurs. SD lights when sending the data. Flashes when sending the data on the data link. RD lights when receiving the data. Flashes when receiving the data on the data link. 5 to 1 5.2 Error detection on this controller. 5.2 Error detection on this controller. When this controller detects an error, it displays one of the error messages listed below. E0956 communication trouble has occurred. The following causes are possible. Trouble in the CC link board. Broken or disconnected cable. Mismatched baud rate. Erroneous node address setting. Remedy communication resumes when the trouble above is remedied. E0957 system trouble has been detected. The CC link configuration file does not exist, or its contents are illegal. Remedy on the Fieldbus hardware setting screen. Check whether the CC link settings are correct. E0958 trouble has been detected by the communication board's self-check function. The CC link board may have a defect. Remedy replace the CC link board. E0959 communication board cannot be found. The CC link board specified on the constant setting screen cannot be found. Remedy check the slot ID among the Fieldbus hardware settings. If this error occurs even if the CC link board is connected correctly, the CC link board itself may have some defects. Replace the CC link board. E0960 some or all I/O links are shut down. I/O links are shut down. Remedy operation is automatically restored when the problem is solved. It may be necessary to turn off the power and turn it back on again in order to solve the problem. I3960 some or all I/O links are shut down. I/O links are shut down. Remedy operation is automatically restored when the problem is solved. It may be necessary to turn off the power and turn it back on again in order to solve the problem. Asterisk as to E0960 and I3960. Either of errors set on the error details setting screen is output. For details, refer to information in 5.3 detail setting of Fieldbus error. 5 to 2 5.3 detail setting of Fieldbus error. 5 to 3 5.3 detail setting of Fieldbus error. For operations when an I/O link error occurs, the following settings can be made. Type of error when a communication error occurs. Method of resetting the communication error when communication is recovered. The following section shows the method of settings. 1. Select constant setting. 8. Communication. And then 3. Fieldbus. The setting screen shown below appears. 2. Press down the F8 Fieldbus error details setting key. Following screen now appears. Supplement HMS timeout is not used in this function. Not to be changed. +3 Select error or information with enable and the right or left cursor key. If an I/O link error occurs if error is selected, E0960 will occur. If information is selected, I3960 will occur. +4 Select error resetting or automatic resetting with enable and the right or left cursor key. If a communication error is recovered if error resetting is selected, the communication error will be held until it is reset. If automatic resetting is selected, the communication error will be automatically reset. If an error occurs in the setting of communication error, this item cannot be selected. 5. Press down the F12 complete key to save the settings. 5.3 Detail setting of Fieldbus error. 5 to 4. Note.